As spring creeps ever closer to the official first day of summer, a lot of the neighborhood talk is about the birds, the bees, and mostly about the sun. Humans smile more on a sunny day. Last year and this year, solar astronomers have even more to grin about. Scientists now feel we are heading towards solar maximum sometime in this July, although true maximum could happen anytime between October 2024 and November 2026. Back in August through September 2024, the highest ever amount of sunspots was reached with an average of 215.5 per day being recorded. To add to this excitement, the ESA's solar orbiter has now come within 42 million kilometers of the Sun and is giving us new views of the Sun's north and south poles. The solar orbiter is not the first spacecraft to image the Sun's poles. The ESA, NASA/Ulysses spacecraft observed the North Pole in 1994 and the South Pole in 1995. But Ulysses was 200 million kilometers away from the Sun. The solar orbiter can get so much closer because it isn't traveling on the ecliptic as most spacecraft do. So what makes the poles of our star so interesting? Scientists are eager to get a closer look at the Sun's poles because they hold vital clues to the Sun's behavior. Our star follows an 11-year cycle called the Solar Magnetic Activity Cycle, during which its activity peaks and then subsides. During solar maximum, more sunspots appear and the Sun produces more storms. Since these storms affect Earth, think auroras and interrupted communication systems, scientists want to know how the cycle works and how they can predict powerful storms. Solanki is the principal investigator for the solar orbiter's Polarimetric and Helioseismic Imager, PHI, one of the spacecraft's 10 instruments. Solanki, also a director at the Max Planck Institute for Solar System Research in Germany, states, "We didn't know what exactly to expect from these first observations. The Sun's poles are literally terra incognita." The PHI captured this image. The blue areas indicate a positive magnetic field, and the red indicate a negative magnetic field. The Sun's magnetic fields are far more complex than Earth's. They appear to be in a constant state of turmoil. Outside of the poles, the Sun features many small complex magnetic structures that vary over time. These structures occur in connection with other features like sunspots and generate the star's large-scale magnetic field. During most of the solar cycle, the large-scale magnetic field resembles a bar magnet, with the Sun's geographic poles lined up with the magnetic poles. During solar maximum, the Sun's magnetic poles reverse. The solar orbiter arrived in just the right spot at just the right time to give us new and amazing views. This collage shows Solar Orbiter's view of the Sun's south pole on 16th to the 17th of March 2025 from a viewing angle of around 15 degrees below the solar equator. The data is from the Polarimetric and Helioseismic Imager, PHI, the Extreme Ultraviolet Imager, EUI, and the Spectral Imaging of Coronal Environment, SPICE, instrument. PHI captures the visible light sent out by iron particles, top left, revealing the Sun's surface or photosphere. As previously shown, PHI also maps the Sun's surface magnetic field along the spacecraft's line of sight, that's in the top center. EUI images the Sun in ultraviolet light, top right picture, revealing the million-degree charged gas in the Sun's outer atmosphere, the corona. The SPICE instrument, various wavelengths bottom row, captures light coming from different layers above the Sun's surface, from the chromosphere right above the Sun's surface all the way to the Sun's corona. I kind of want this whole image as a poster. After another flyby of Venus in December 2026, the solar orbiter will be able to get even better views of the Sun's poles from a 23-degree angle. The Earth's magnetic fields may not be as complex as the Sun, but we do have something going on here as well. We have the South Atlantic Anomaly. The bulk of Earth's magnetic field originates deep within its core, at the boundary between the molten outer core and the solid mantle. The magnetic field extends past the surface into space and acts like a protective shield around the planet, repelling and trapping charged particles from the sun. But over South America and the southern Atlantic Ocean, an unusually weak spot in the field called the South Atlantic Anomaly, SAA, allows these particles to dip much closer to the surface. NASA released a concerned statement about the weakening status of the SAA at the end of this May. NASA's concerns over this geomagnetic phenomenon are as fascinating as they are worrying. The SAA is an immense region. The weakening of this area, far from being a mere scientific curiosity, acts as a breach in our natural protective shield, allowing high-energy solar particles to come dangerously close to the Earth's surface. Particle radiation in the SAA can knock out onboard computers and interfere with the data collection of satellites that pass through it. Some satellites pass through the SAA 8 times a day. Think perhaps Death Star vulnerability in reverse. So whether you are sun-tanning while reading about satellites skipping through Earth's SAA, sketching sunspots by gazing through your solar scope, or hoping for a solar flare storm to create an evening aurora, our sun truly is the star of the summer season.